In this video, I'll explain how to make the long legs stand system for the PUMA microscope. I've already shown how to fit the long legs stand system to the scope in the video on the Abbe condenser, so please see that video for fitting instructions. The basic foundation scope has a mirror illuminator only, so requires minimal clearance space underneath the scope. This is provided by the standard short legs system, which was described in the video on how to build the PUMA foundation scope, so see that video for details on the short legs system. The light sink condenser used for epi-illumination configurations can also be used with the standard short legs system. However, most other PUMA substage modules, such as those that use the Abbe condenser or polarizing illuminator, will require the additional clearance provided by the long legs stand system, which I'll describe in this video. These are the parts and the tools you'll need to build the long legs stand system. Details are provided in the video description. As always, the first step is to remove any 3D printing support structures and clean the parts from any 3D printing artifacts. In this case, we'll need to remove these supports from the feet linker component. Take care not to cut yourself and wear eye protection, because fragments may fly off while you're doing this. Now prepare the front legs by placing 4 M3 nuts into their recesses. If you have difficulty sinking these nuts in fully using simple pressure alone, you can use a screw and washer to pull them all the way in. Now attach the feet linker component to the front legs component with 4 M3 screws and washers as shown. The threaded part of each screw is 10 mm long. Now construct the thumb screw for the hind leg by inserting the M3 hex bolt into the plastic thumb screw receptacle, ensuring the hex head is sunk into the depression, and fix it in place with an M3 nut on the other side. Now insert the M4 grub screw into its hole in the hind extension component. You will be cutting the thread for this grub screw as you insert it for the first time. So take it slowly and insert it all the way through into the inside, but then retract it again so that it does not protrude into the lumen. Check that the cavity in the hind extension component fits properly over the back leg angled component. Clear any 3D printed artifacts or stray plastic that might hinder this. Now thread the 16mm long M6 hex bolt into the hind extension component. When you do this for the first time, you will be cutting the thread into the plastic, so it may need some force, and you should take it slowly. Go in a few turns, then unscrew it partially before continuing for another few turns, etc. Insert the plastic head cap to the head of the M6 bolt to complete the manually adjustable hind leg assembly, as shown. Now insert an M3 nut into this hexagonal recess in the hind leg hole in the feet linker component. This can be a bit fiddly. Essentially, you want to use the M3 thumb screw to drag the nut all the way into the recess. When you thread the nut into the thumb screw, take care to ensure the nut is orientated correctly with respect to the hexagonal recess for it, before you pull it into the recess by tightening the thumb screw. Finally, unscrew the thumb screw so that it no longer protrudes into the hole, and check that the back leg angled component can be freely inserted into the hole. The long leg stand system is now ready to fit to the base plate of the PUMA microscope, as was shown in the video on the Abe condenser. Please remember to like, comment and share this video to support the PUMA open source microscopy project. Thanks for watching.